Hey everybody, this is Mr. Mott. We're going to go over how to do some of these more complicated stoichiometry problems involving the moles and grams. The method is going to look a little bit shorter. However, it's the same amount of work, but visually it can be a little bit easier for everyone to follow. Okay, so we're going to start out with our chemical reaction, and so it starts out with 2Al plus 6HCl producing 2AlCl3 and 3H2. Now, a chemist wouldn't read the equation like that because we know that these coefficients in front, these numbers represent moles. So it's a good idea to go ahead and write that in. So you're starting out with 2 moles of aluminum, 6 moles of HCl, producing 2 moles of AlCl3 and 3 moles of H2. Okay. Now, once we sort of recognize that, we would know the ratio that we need to sort of mix our chemicals. However, we have a problem. I can't go out into my lab or my balance and measure out moles of aluminum or moles of HCl. I first have to convert it to grams. So what we're going to do is convert these to grams. I'm going to take 2 times the molar mass of aluminum, and for aluminum that's 27 grams. So I do the math there, it's going to be equal to 54 grams. So what we've calculated there is that 2 moles of aluminum is equal to 54 grams. Okay. We'll do the same thing for HCl. We're going to take 6 times the molar mass of HCl, which is 36.5 grams. So I'll take 36.5 times 6, and we get 219 grams. And on the product side, we'll do the same thing. We'll take 2 times the molar mass of AlCl3. The molar mass of AlCl3 is 133.5. So that equals 267. And we'll take 3 times the molar mass of hydrogen, which is 2 grams. Okay, and that's equal to 6 grams. Now, a little side note about this, if we wanted to think about how the law of conservation of matter works and is it preserved here? If you add these two up, the masses of our reactants, it should equal 273, and that's the same on our product side. So the law of conservation of matter is conserved, which is sort of a kind of a neat aside. All right, so now let's think about doing some calculations with these. And we'll first start out with a mole-to-mole calculation. Okay, so let's say that we had 13 moles of aluminum, and we wanted to know how many moles of hydrogen that we could make. So I'll start out by writing my given and my want, 13 moles of aluminum, and what we want to find out are moles of hydrogen. And one change that's going to take place here is that all of our calculations are going to look like one-step problems. Once we've done all the work that we did converting into grams, everything now will look like a one-step calculation. Okay, so I'll put moles of aluminum on the bottom so that these units cancel, and we'll put moles of H2 on top. Those are the units that we want. We're going to go to my equation looking for moles of H2. Okay, in our equation, moles of H2, the number of moles is 3. So put that on top. And then I'll look for moles of aluminum. So I need to know what number goes with that. And that number is 2. Okay, so I'll put a 2 on the bottom. Okay. My units of moles of Al cancel. And now we're left with doing the math. So 13 times 3 divided by 2. My answer in the end will be 19.5 moles of H2. Okay? So that seems really straightforward, and you might be wondering, well, why did we do the grams calculations here before? Well, that's what we're going to show you next. Okay? So I'm going to take all of this, and I'm going to get rid of it now. And we'll start out and show you a new calculation with this. Okay? And I think I forgot my grams here. Okay, so now let's do another one. Let's say that we had 100 grams of aluminum, and I wanted to know, for instance, how many moles of hydrogen that I would make. Okay, so we're going to set up the problem in a one-step situation here, and this is where things look a lot simpler for a lot of folks. Okay, we're going to put grams of aluminum on the bottom and moles of H2 on top. Okay. Now the reason we can do that is because we've already figured out all of the ratios how things are going to react. Okay. Originally, we said that for every 2 moles of aluminum, you will make 3 moles of hydrogen. Okay. But it is also true that if we have 54 grams of aluminum, you will make 3 moles of H2. And so because 2 moles of aluminum is equivalent to 54 grams, we can interchange those. Okay, so I'm going to put next to my grams of aluminum on the bottom, I'm going to put the 54. And for my moles of hydrogen, it's going to be a 3 from my equation. Okay, canceling out some units, my grams of aluminum cancel out. I'm going to take 100 times 3 and then divide by 54, and we get about 5.56 for my answer. 5.6 depending on how we round. Okay. So that's kind of how we can arrive at some of these in sort of a condensed way. No matter what problem we have, when we're comparing one chemical to the other, we're going to have to use information from the equation. The big change is what we did here by figuring out how many grams were equivalent to the moles in the calculation. Okay, let's try another one. Okay, and this time we'll do a gram to gram problem. Okay, let's see, I have my grams there. All right, so let's say now that we try, let's say that we have 50 grams of HCl, and we want to know how many grams of AlCl3 that we would produce. Okay, so again, we're going to set this up in a one-step problem, and so we'll go 50 grams of HCl, and we want to know how many grams of AlCl3 that we would make. So we're going to have to put grams of HCl on the bottom, so those units cancel, and we'll put grams of AlCl3 on top. Okay. This over here. We're comparing two different chemicals here, AlCl3 and HCl, so that information has to come from our equation. Since our units are in grams, we're going to get the units of grams that are associated with both. So for grams of AlCl3, we calculated that at 267, so that's what we're going to write on the top. And then for HCl, gram to HCl, we calculated that at 219. Okay, so we'll write that on the bottom. My units of grams of HCl cancel, and now it's a matter of doing our math. So we're going to take 50 times 267 divided by 219. And we get about 60.96, maybe we'll round that to 61, depending on how we wanted to round things. Okay, so that's 61 grams would be our answer. Okay. Now, one thing that I'll make clear about this, it's very important. First step I would do in this is I would write down how many moles are equal to the numbers there. Even though they're written in the equation, the units of moles are not they're not written, they're understood. So in the beginning when you're first learning this, I would write how many moles there are, and then you'll figure out how many grams are equal to the moles as you need them. Okay. Let's try maybe one more. And let's see here. So let's say that I had 100 grams of HCl, and I wanted to know how many grams of aluminum that I would need to sort of completely react with it. So in the other examples, I'd been using one reactant and one product. Here, I'm living sort of on the reactant side, and that's definitely possible as well. So I'll set this up as, a one-step problem again. So 100 grams of HCl, and I want to know how many grams of aluminum I would need. Okay, so we would put our grams of HCl on the bottom so that they cancel, and then grams of Al on the top because those are the units that we want. For my grams of aluminum, I know that the 2 moles from my equation is equal to 54 grams. So I'll write 54 on the top. And for my grams of HCl, the 6 moles in my equation is equivalent to 219 grams. So I'm going to write 219 on the bottom. Okay. My units of grams of HCl cancel out. And now it's a matter of doing the math here. So I'm going to take 100 times 54 divided by 219. And we get about 24.7 for my answer. Okay. So this is your condensed method. It definitely doesn't replace sort of the traditional method, but if you do have trouble following all the steps and knowing where to get all the numbers from, this could be a viable option for you. Okay. Thanks for watching.